Alright, my name is Brayden Hamm. I'm part of Professor Dahlquist CpE64 class this semester for Springs 2017, and I'm going to show you how to display your name using a 7-segment display. So first of all, how does a 7-segment display work? Well, there are actually 8 segments if you count the dot, which you can see on the screen in that picture, but the main part of it is 7 segments, like you would see in an alarm clock. And they're labeled A, B, C, D, E, F, G because each input is connected to one of those segments. So if you see that on the top of this segment is an A, there's also the top segment is A. So if that lights up, that's lights up because in this example we have a common cathode. And so it naturally it's at a 0 state, so all of them are low. But when an input is high, it is high, so it's an active high input. So that's how a 7-segment display, so if you get an input into A lights up. And so first of all, you're going to want to start with a state diagram like I have here. My name's Brayden, B-R-A-Y-D-E-N, so I have 7 states, starting with B, the first letter of my name, going all the way to N. And then what I wanted to do was create a loop, so when I got to the end the state which is N, I went back to the first state, which is B. And then other than that, it just goes to the next letter of my name so that it would do a loop. So after it got to the end, it would start my name all over again. And here's the truth table for that state diagram. So that you can see I have the state number that it's in, so 0 to 6. And then I have what it should look like in the 7-segment display column of the output. And then A through G are whether that certain segment is either high or low. And then using that truth table, I was able to create a module in Verilog pretty simply. So on the positive edge of the clock, it switches to the next state. And then always when there's a state, goes through, figures out which states it's in the case statement, you can see, and then changes the display to be what it should be for that state, and then changes the next state for what it should be for that state. And it always increments by 1, except number 6, which is the letter N, should go back to the beginning, which is state 0. And initially I have it set to be at state B. And then here's the final product on the breadboard. I used the white wires for easy access to the A, B, C, D inputs because otherwise it would just be a mess all around the 7-segment display to where you could barely see the 7-segment display itself because some inputs are on the top, some are on the bottom. And then the black and white wire that twirl around each other, that's going to be the positive and negative. And the blue wire that's hooked up to the 7-segment display goes to ground. And then on one of the buttons on the FPGA is the clock pulse. So when you press that button, it changes the letter. Alright, and that's it. Thank you.